All right, so 5.4, adding algebraic fractions. Adding and subtracting came after multiplying and dividing because they are actually more complicated than multiplying and dividing. So let's review the basic facts about adding and subtracting fractions. So let's do 1/2 up here in the margin. If I want to add this or subtract it to 2/7, I cannot simply add 1 plus 2 and 2 plus 7. These need to be in terms of the same whole, meaning they need the same denominator. So oftentimes that common denominator is just going to be by multiplying our two denominators together. So if I want, which would be 14. So obviously, to make the first fraction have a denominator of 7 or 14, I need to multiply top and bottom by 7. I don't want to change the value of it, so essentially we're just multiplying by 1. Likewise, for 2/7, I need to multiply that by 2/2, essentially multiplying it by 1, and that changes it to 7/14 plus 4/14. Now I have different parts of the same whole, meaning the denominator, in terms of 14. So I have 7 parts plus 4 parts, which means I have 11 total parts out of the whole of 14. 11/14. I know this is a very elementary example to start with, but adding and subtracting fractions is something most people shy away from and make lots of mistakes doing. So I did want to make sure I cover the basics. So now let's look at rational expressions. So let's throw in some variables. So 3/x cubed minus 1/2. I'm going to rewrite this so I have more space. 3/x cubed minus 1/2. I need a common denominator. In this case, again, it's going to be just from multiplying my two denominators together. My common denominator is going to be 2x cubed. So for the first fraction, I'm multiplying by 2/2. The second fraction, I'm just going to multiply by x cubed over x cubed. So what does this result in? This results in a single fraction. Change my colors. My denominator is now 2x cubed, and my numerator is 6 minus x cubed. So 6 minus x cubed over 2x cubed. Can I simplify this at all? No, I cannot. So this, actually, I'm going to stop right there. Many of you, it's okay if you're one of these people, just stop being that person. You cannot cancel those two out. I see it on almost every problem like this on multiple papers. So why can we not cancel those out? I see an x cubed here and an x cubed here. Why can't we just cancel those out? X cubed over x cubed is 1. But that is not the case when the term is being separated from the other term with addition or subtraction. It just doesn't work like that. Fractions don't work like that. So, okay, shoot. Now I can't uncircle those. But our answer here is just 6 minus x cubed over 2x cubed. I can't cancel out my x cubes, even though I know some of you really want to. But I promise you, you can't. X cannot be 0 because 0 cubed is 0 times 2 is 0. Are there any other restrictions? No, that's the only restriction. X cannot equal 0. Before we move on, I'm going to convince you why we can't cancel out those x squareds. Let's plug an example. Let's plug an actual number in for x, and you'll see why. Let's say I plug in 2 for x. That would be 6 minus 2 cubed over 2 times 2 cubed. So if I were to just cancel these out, what would that be then? Would that just be 6 minus 1, 2 cubed? Those are gone. 6 minus 1 over 2, which is 5 halves. Is that the same thing as when I don't cancel them out? 2 cubed is 8. 6 minus 8 over 2 times 2 cubed, which is 8. No, these are very different numbers. 1/8 is not the same as 5/2. You just can't do it because they're separated by addition or subtraction. So make sure you're really cautious about quickly canceling things out. Okay, so problem 2. 1 over x plus 1 minus 1 over x minus 1. This is a tricky problem, and I often get people wanting to say the common denominator is x plus 1, or it's x minus 1 squared. And that is not the case. In this one, x plus 1 and x minus 1, imagine plugging a number in for x. Let's say we plug in 3 for x. That would make this denominator 4 and this denominator 2. Let's say we plugged in 7 for x. That would make this denominator 8 and this one 6. They're completely different numbers. There's no way to mesh those two together, just other than just multiplying the two denominators together. So the common denominator here is the product x plus 1 times x minus 1. So I'm going to rewrite this so that I have a little more space. I'm putting these in parentheses just to help us go through the process correctly. So the common denominator is x plus 1 times x minus 1. That means I need to multiply this first fraction by x minus 1 over x minus 1. And I need to multiply the second fraction by x plus 1 over x plus 1. This will result in my sum with a denominator of x plus 1 times x minus 1. The numerator is where you need to slow down and be careful, because I see a lot of common errors arise here. The first being that this is a subtraction problem, meaning whatever comes after that subtraction, I need to distribute that minus sign. So I'm subtracting x plus 1, which means I'm going to be subtracting x and 1. So from this fraction, I end up 1 times x minus 1, which is just x minus 1, minus the whole quantity, x plus 1. So what that really gives me is x minus 1 minus x minus 1. So my x's subtract out. X minus x is 0. And I'm going to get my final sum of, so those are gone, -2, because I have -1 minus 1, over my common denominator of x plus 1 times x minus 1. And that is my sum. Don't forget the restrictions. X cannot equal, in this case, plus or minus 1. Okay. So let's move on to a little bit more of a complex problem, and then I feel like we'll be at a good stopping point. So with this one, always factor first, just like the last time on 5.3. If you can factor, factor. So first we see x squared plus 1. I cannot factor it. If that was x squared minus 1, that would be great because it's a difference of squares. But I can't factor x squared plus 1 over the real numbers. So I'm going to leave it. And then my denominator, x squared minus 4x plus 4, I can factor that. The two numbers that would multiply to positive 4 and add to negative 4 would be x minus 2 times x minus 2. I'm going to add that. Okay, so then on my second fraction I see x squared minus 7. That I could factor. It is a difference of squares, but we don't need to worry about factoring it because it's definitely not going to have a common factor, because 7 isn't a perfect square, so I'm not going to worry about factoring that. The denominator does factor what multiplies to -6 and adds to positive 1. That would be x plus 3, x minus 2. Remember, our goal here is to add the fractions together. I'm not solving for x. I'm not trying to eliminate the denominator. I simply want to combine these two fractions into one single fraction. To do that, I need a common denominator. My denominator here is x squared, or x minus 2 times x minus 2. I see this x minus 2 here, but I need another one because if this first fraction has two of them, I need x minus 2 squared represented over here as well. So what I would have to do is multiply the second fraction by x minus 2 over x minus 2. So I'm going to add parentheses here. And then to the first fraction, what it's missing is this x plus 3, which means I need to multiply the numerator and denominator of the first fraction by x plus 3. So, as you may have guessed, this is going to be a long process. I have two separate things that I need to FOIL or distribute, whatever you want to call it. And now I have my common denominator. It's x plus 3 times x minus 2 times x minus 2, or x plus 3 times x minus 2 squared. That's going to remain the denominator. I do not need to distribute that out, but I do need to distribute the numerators and make any cancellations if I can. Or simplify it. So my first one, I'm going to start up here. X times x squared is x cubed. X times 1 is 1. 3 times x squared. Hold on. I messed up. Alright, so we have x cubed plus x plus 3x squared plus 3. So that comes from just multiplying that out. I'm going to add that. I'm going to switch colors just to clarify. I'm moving on to, let's do orange, multiplying this out now. So x squared times x is x cubed. Take your time on these. It's easy to get lost in the details. Okay, so x squared times negative 2. So that's negative 2x, negative 7 times, negative 2x squared. Negative 7 times x is negative 7x, and negative 7 times negative 2 plus 14. Okay, so that's our new numerator after we multiply everything out all over the same denominator of x plus 3. Times x minus 2 squared. So we're almost done here. Now I just need to combine like terms in this crazy numerator. So I'm going to switch to another color and start combining like terms. So I've got x cubed here. I've got x cubed here, which means I have 2x cubed. And then I've got 3x squared here and negative 2x squared, so that would just be 1x squared. And then I've got an x term here, minus 7x, so that would be negative 6x. And then my last thing would be to add 3 plus 14. All over x plus 3 times x minus 2 squared. Okay, so that is the sum. We were simply writing this as a single fraction in lowest terms. I want to reiterate, we were not solving. We just get a common denominator, add them together, and simplify as much as we can. So this is adding rational expressions or subtracting. Don't forget your restrictions. From our numerator, cannot be negative 3 or positive 2. Okay, I'm going to stop here just because that gives you the main info you need to do to work on the front page of your homework only. We will finish this section of notes on Friday when I am back, and then you'll be able to finish that assignment. All right, y'all, see you later.